The first term of an arithmetic series is 4 and the fifth term is a 10. Okay, so it's an arithmetic sequence, and for the first part we are told to find the 30th term of this series. So let's look at how to do this. It's an AP because it's an arithmetic sequence, right? Arithmetic progression with the first term. First term, of course, we denote it with the alphabet A. So A equals to 4, and we are told that the fifth term is 10. That means T5 is 10. Now, what would be the T5 in terms of A and the common difference? So T5 would be A plus 4D because n minus 1D. So 5 minus 1 is a 4. So 4 times D is equals to 10. Now, since we already know the value of A, so it's easy for us to find the value of the common difference D by substituting the A with a 4. So if I substitute the A with a 4, so I get a 4 plus 4D equals to 10. And let's find out what's the common difference. So 4 times the difference is equals to 10 minus 4, which is of course equals to a 6. Now if 4 times the common difference is equal to 6, so how much is the common difference D? Common difference is of course 6 divided by 4, which reduces to 3 over 2 or 1.5 or 1.5. So whichever way it is. Okay, so D is equals to 3 over 2. Now we are told to find the 30th term of this series, okay, for 2 marks. So 30th term means T30. So of course when you write T30, we're going to use the formula A plus n minus 1D. Of course when n is at 30, so we're going to get 29 times the common difference. So A plus 29D. Now since we already have the value of A and the common difference here we just worked out, which is 3 over 2, we can substitute these two values to work out the 30th term. A is a 4 and 29 times the common difference, which is 3 over 2. And when we simplify that, it's going to become 4 plus 29 times 1.5 or 29 times 3 over 2 is 43.5. So to 43.5 you add another 4, that's going to become 47.5. So there we have the 30th term of this series. Now in the part 2 we are asked to find the sum of the 21st term to the 50th term inclusive of this series. So it's not 1 to 50th term, okay? So we need to find from the 21st term to the 50th term. So how we're going to tackle this is we are going to calculate from the first term to the 50th term, right? So that would give us the sum of 50 terms, and then we minus off the first 20 terms, sum of the first 20 terms, and of course what will be left would be the 21st term to the 50th term's sum. Okay, so now let's keep the values of A and D, and now let's work it out. So the sum S is going to be equals to sum of the first 50 terms, and then we subtract away the sum of the first 20 terms. Okay, that would give us from 21st term to the 50th term inclusive, right? So let's use the formula for S50 or sum of n terms of an arithmetic progression, which of course you should remember that it is n over 2 times 2a plus n minus 1d. So okay, n over 2, so of course n in this case is 50, so 50 because we're going to add 50 terms, 50 over 2, okay, open bracket, 2 times a, okay, where a is 4, okay, plus n minus 1d. N minus 1 is of course for the 50th term, so 50 minus 1 is going to become 49 times the common difference, which is 3 over 2, and this would actually give us the sum of the first 50 terms of this progression. Now let's do the same thing, okay, for sum of 20 terms. So 20 over 2, and then open bracket, 2 times a, which is again 4, plus n minus 1. Okay, so 20 minus 1 of course going to become 19 times the common difference, which is 3 over 2, right? So if we evaluate this this expression completely, so we're going to get the sum of 21st term to the 50th term inclusive. So let's just simplify this. 50 over 2 is of course 25, twice of 4 is an 8, So 49 times 3 over 2 is going to become 73.5, and then 20 over 2 is of course 10, and twice of 4 is 8, plus 19 times 3 over 2, that would be 28.5. So now let's simplify what is inside the bracket. 8 plus 73.5 is going to give you a total of 81.5, and 8 plus 28.5, if you add up, it's going to be 36.5, and we can now multiply by the number outside the bracket, which is 25 times 81.5. That would be 2037.5, which is basically the sum of the first 50 terms of this sequence, and 10 times 36.5 is 365, and let's perform the subtraction, and what you're going to have is 1672.5 is the sum of all the terms from 21st term right up to the 40th term of this particular series. Now for the part B, this is about a geometric series. Okay, so we are told that the first term of the geometric series is 4, right, and the fifth term is 1.6384. So as you can see, the first term is bigger and the fifth term is getting smaller and smaller, right? So, and the common ratio we are told is positive, of course. So the first term of the series is 4, that means it's a GP with A equals to 4. A is always used as the first term, or you can call it U1. Okay, so whichever way that you're used to calling it, it doesn't really matter. So A is equal to 4, and we are told that T5, that's the fifth term, is equals to 1.6384. The formula for the nth term of an arithmetic progression would be a r to the power of n minus 1, and of course we already have the a, which is 4, right, and the common ratio we do not know yet, so let's just keep it as r, okay, to the power of n minus 1. So in this case it's a 5, so 5 minus 1 is going to be equal to 1.6384. So let's now substitute the a with a 4, and 5 minus 1, of course the power for the r is going to be a 4, is equals to 1.6384, and now let's divide, okay, the 4 over to the other side. So we're going to have r to the power of 4 is simply 1.6384 divided by 4, and which is actually equals to 0.4096. And if you want to calculate the fourth root of this number, that would give us the value of the common ratio, which in this case happens to be 0.8. There we have the common ratio for the given geometric series. Now what we need to find out is that, of course, the reason why I have to show that since r is greater than 0, because we are told that the common ratio is positive. So r to the power of 4, if you actually find the fourth root, it could also be negative 0.8. So we need to ignore that, because we are told in the sequence that the common ratio is positive. So that's the reason why I took r equal to 0.4 and rejected the r equals to negative, r equal to 0.8, and I rejected r equals to negative 0.8. Now what we need to find after we find the common ratio as well as the first term is to find the sum to infinity of this series. And as you can see, the common ratio is less than 1, and of course sum to infinity will exist because this is a converging sequence. So S infinity, the formula for sum to infinity of a converging sequence will be a over 1 minus r. So we're going to use that formula. A is the first term, of course in this case a is a 4, so the common ratio we have already worked out is 0.8. so 4 divided by 1 minus 0.8, and that's going to be 4 over 0.2, which is going to simplify to 20. So if you're going to keep adding it up all the way to infinity, so the total sum would be just 20. So there we have the sum to infinity of the series. Now let's look at the part 2. We are told that given that the sum of the first n terms is greater than 19.6, show that 0.8 to the power of n is less than 0.02, and thereafter we are supposed to find, hence, that means using what we showed earlier, find the smallest possible value of n. So let's look at how we can tackle this. So sum of first n terms, okay, so Sn, okay, of course it will be given by the formula a times 1 minus r to the power of n over 1 minus r, because it's a converging sequence. So a is the first term, r is a common ratio, n is number of terms n. So because we are looking for sum of first n terms, so let's keep it as n itself over 1 minus r. Okay, so this we need to prove, given that, oh sorry, this is already given that this is greater than 19.6. so therefore I form the inequality here. So now let's throw in all the values. Okay, a is a 4 and r is 0.8, okay, to the power of n over 1 minus 0.8 is greater than 19.6. so now let's cancel this, because 1 minus 0.8 is of course going to become 0.2, and 4 if you divide by 0.2 it's going to give you a 20. So that's how I got the 20 here. Whatever that's inside the bracket, I'm just keeping it as it is, and this is greater than 19.6. so now let's divide both sides by a 20. Okay, so since I'm dividing by a positive number, I do not need to reverse the inequality, so it would be simply 19.6 over 20. So 1 minus 0.8 is therefore greater than 0.98. Now what I'm going to do is, okay, throw this 0.8 to the power of n, sorry, here in this case I have just kept it on the left side, throw the 1 across to the other side, so it's going to become minus 1. So 0.98, from that if you subtract the 1 it's going to become negative 0.02, and of course if I multiply both sides of the expression by negative 1, the inequality sign would reverse. So negative 0.8 to the power of n, if I multiply by minus 1 it's going to become 0.8 to the power of n. Inequality has been reversed. Negative times negative 1 is going to give you positive 0.02, and there we have, okay, shown what we are required to show. 0.8 to the power of n is less than 0.02. And then the next part says, hence find the smallest possible value of n. So of course since the n is in the power, in order to bring down the power to the front, so we need to take log to both sides. So I'm taking the natural log. So ln 0.8 to the power of n, if I were to take it on the right side, it's going to be less than ln of 0.02. And let's bring the n to the front by using one of the laws in indices. We know, in logarithms, we know we can bring the n to the front. So we will have n times ln 0.8 is less than ln 0.02. And take note, any ln of any number that is less than 1 is going to be negative. So ln 0.8 is going to be negative number. So of course in the next step I am going to bring it over to the right side and going to start dividing it. And of course when you divide an inequality by a negative number, the inequality sign is supposed to reverse. So that's why the less than symbol has changed to a greater than, as I throw the ln 0.8 to the right hand side to divide. So just take note of this step. So this step, it's very easy for you under examination condition to get stressed up and forget to reverse the inequality. So all the rest that you need to do is just to press into your calculator. So n is greater than ln 0.08, and if you divide that by ln 0.8, ln 0.02 divided by ln 0.8, it should be about 17.5. So we know that n must be an integer number that must be greater than 17.5. So what would be the smallest number that n can be? Of course it can be 18, 19, 20, 21. So but it is saying smallest possible value of n. So out of all the numbers, the smallest value of n should be 18, and that should be the answer for this. And if you do this correctly, so for this part you would have gotten another 5 marks.